So we're doing OCR's maths paper from November 2018. It's paper 2, the non-calc paper, and this is a foundation paper. And if we just have a look at the grade boundaries, you'll see we need 52 marks for a grade 4 and 61 marks will get you a grade 5 on this paper. So question 1, we've got a hexagon and we're just looking for the two lines of symmetry. And lines of symmetry are just mirror lines. So where does this shape look the same on both sides? There's one straight up and down, and there'd be a second straight across like that. Part B says write down the order of rotation symmetry. Well, for rotation symmetry, you've got to imagine the shape spinning around and then count how many times it looks exactly the same as it currently does. Well, there's one at the very start, and then if you imagine this goes all the way down to the bottom, when this arrow comes up to the top, it would look exactly the same. So there are 2 times when you go in a full circle that shape looks exactly as it does now. Question 2, we've got some number work to do. First question is half of 12, and hopefully you know that half of 12 is 12 divided by 2, and that is just 6. Part B says what's 8 times a fifth? Well, if you're timesing a whole number by a fraction, you only ever times the top number by that whole number. So 8 times 1 is 8, and we leave the fifths as fifths. It does say give your answer as a mixed number. So if I've got 8 fifths, well, 5 of those fifths is the whole 1. And if I've used 5 of these fifths, there are 3 left. 8 fifths is 1 whole 1 and 3 fifths. Part C, we've got people eating a pizza. Isaac eats a sixth of the pizza. And if you look at this, it talks about what's left. So straight away, if someone eats a sixth of the pizza, I know there are 5/6 left. Maya eats 3/5 of what's left. Okay, so what I'm going to do is work that out. If Maya eats 3/5 of what's left, the word of in maths can be treated as a multiplication. So Maya eats 3/5 of what's left, 5/6. And if we're multiplying fractions, we just multiply the top. 15, 5 times 6 is 30. 15/30 actually simplifies to the half. We know that that is what Maya eats. Let's just check the question. It says what fraction of the pizza is left overall? Well, we know that Maya eats a half. We know that Isaac eats a sixth. So that is what's been eaten. And what we want to know is what's left. So if I just work this out, 1/2 is the same as, if I times by 3 times by 3, that is 3/6. And I'm going to add that to 1/6. That means 4/6 of the pizza has been eaten. What's left? 2/6 left. Question 3, we're looking at a triangle and we've got these special marks, and these special marks mean all sides are the same. That is an equilateral triangle. Part B, we've got some names of special quadrilaterals. Quadrilaterals, just 4-sided shapes. It says choose a quadrilateral from the list that satisfies each of these. So I want all 4 sides the same and opposite angles equal. So all 4 sides the same, opposite angles equal. That's going to have to be a pushed over square. The fact that it's got all 4 sides the same means it's got to be based on a square, and that's called a rhombus. Then we're looking for 4 angles or right angles, and the opposite sides are equal. Well, if we've got right angles, it's got to be either a square or a rectangle. And this thing that says opposite sides are equal means they're the same. and they're the same. So that is a rectangle. And then down at the bottom, we've got a square base pyramid. And we're talking about faces and edges. Well, these are your edges. And you can see that there are 8 of those. Your faces are the flat things that you can see. So I'll try and colour these in. There's one at the back there. There's another one at the back. There's one on the very bottom. And then this is where it might get a little bit confusing. There's one at the front. And another one at the front. Altogether, 1, 2, 3, 4 around the sides and 1 on the bottom makes 5. Before, we've got some heights of players in a netball team, and we're asked to find the median. First thing we need to do when finding the median is put these into order. So I'm just going to start looking through these. The smallest is 1.13. The next is 1.15, just looking at that second set of digits. The next biggest player is 1.20. Then 1.22, 1.23. Then 1.24 and 1.30. If we're asked to find the median, we want the middle player when they're in order. So I'm just going to start crossing off left and right. The middle player is 1.22. We then have found the range. Well, range is biggest, take smallest. So I'm going to do 1.30, take away 1.13. This is a non-calculator paper, so we need to work this out. 0 take 3 can't do, so borrow from there. 10 take 3 is 7. 2 take 1 is 1. Decimal, decimal, decimal. And 1 take 1 is 0. The range is 0.17. We're told that the sum of these players, so someone's added them together, comes to 8.47. And we need to do the mean height of the 7 players. Well, someone's added them together. Finding the mean is adding together and dividing by how many there are. So we need to do 8.47 divided by 7. I'm going to write that as a bus stop calculation. How many 7s into 8.47? 7s into 8 is 1, remainder 1. We have got a decimal, so we've got a decimal there. 7s into 14 is 2. 7s into 7 is 1. The mean height is 1.21 meters. And then in the final part of this question, we've got the tallest player is replaced. The median is unchanged. So my middle number needs to stay the same, but the mean height becomes smaller. So if my mean is becoming smaller, this tallest player needs to be replaced by someone that's smaller. So I'm just going to write that down. I'm just going to say, well, what if someone who's 1.29 comes in? Okay, having a smaller player will certainly make the mean smaller. And I can just check with this new player in place, does the median stay the same? Well, yes, because I'm just going to cross that one out instead of this one, and my middle person will still be 1.22. So question 5, we've got a graph that shows the cost of buying potatoes from a farm, and it's based on the weight. So here we've got the weight of the potatoes, and then at the side we've got the cost for that weight. It says, how much does it cost to buy 70 kilograms? Well, here's my kilograms, here's 60. 70 must be in the middle there, 60, 70, 80. So all I need to do is read up to the line and then across to the cost and just read this off. It looks like it's going up in ones, but always double check. 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So that comes to £28 there. He then says what weight of potatoes can be bought for £38. So now I'm talking about pounds. Where's my pounds? Here it is. 35, 6, 7, 8 is there. So that's £38. I'm just going to do the same as I did before, but in the other direction. Read across and then read down. And just be careful with your scale here. We've got 80, 90, 100. So each little box must be worth 2. Just double check. 90, 2, 4, 6, 8, 10, 100, yeah. So this would be 90, 2, 4, 94 kilograms. And then part 3 says the cost per kilogram of potatoes is the same for any weight. And what that's telling you is this graph would just go on forever. We could keep going on and on and on. How much will it cost to buy 180 grams of potatoes? Well, we can't use the graph because 180 is not on it. So what we've got to do is find something that we can scale up to 180. And what I'm going to use is this bit in the middle. I'm going to use 60 kilograms because that's bang in the middle of the graph. And if I just write that down, 60 kilograms is 24 pounds. Well, I know that 60, 120, 180, if you times that by 3, you get 180 kilograms. So all I need to do is times my 24 by 3. So I'll do that over here. 24 times 3. 3 4s are 12. 3 2s are 6, and that makes 7. It costs £72 for 180 kilograms. Part B says we've got a graph showing annual profits. It's the same form that we looked at in the part A of the question. And it says, what's one misleading feature of the graph? Well, we're just looking for something that's dodgy on this graph. And if we look here, look, 20, 40, 60, 80, 100. Then we go 110 and 120. So we go up in 20s, then we go up in 10s. So we can say something like, you might want to say it's not linear, meaning it's not going up in the same jumps. You could even get away with saying scale goes up in 20s, then 10s. Question 6, we've got to show which is bigger, 36% or 7/20. Well, we need to compare these with each other. And if you're going to compare fractions, decimals and percentages, you want to choose one or the other. I know that 36% is 36 out of 100. The minute you've got out of 100, you've got percent. So I'm going to change the percentage into a fraction. I've already got 7/20 as a fraction. And if I count up in 20ths, 20, 40, 60, 80, 100, 5 lots of 20 is 100, and 7 times 5 is 35. And then we can see that 36 hundredths is bigger than 35 hundredths. So I'll just write that down. And that is usually enough because we've got the direct comparison. But you can just write something along the lines of, there are more hundredths. Question 7, we've got to just look for the value of this. Well, this is the cube root of 27. So we're looking for something, when you times itself 3 times, comes to 27. 1 times 1 times 1 is 1. 2 times 2 is 4. Times 2 again is 8. 3 times 3 is 9. Times 3 again is 27. So the answer to this, the cube root of 27, is just 3. 7 squared, 7 times 7, which is 49. Be careful, a lot of people do 7 times 2 there. And 6 to the power of minus 1. Well, when you're raising to minus 1, you just put 1 over that number. 6 to the minus 1 is 1/6. 7 to the minus 1 would be 1 over 7, 1/7. So in question 8, we've got some information about a water company's charges. it's £2 for every metre cubed, and then plus just £45. This fixed charge, you just add the £45 on. So let's have a look. In 2017, she used 110 metres cubed, and it's £2 for every metres cubed. So we need to do 110 lots of £2. Well, we're just going to do 2 times 110, which is £220. Don't forget, we need to add on the fixed charge of £45. And if we just add those together, no, add 5 is 5, 2 add 4 is 6, and 2 is just 2. So altogether, she owed £265. Question says that she's paid £20 per month for 12 months. So she's paid 12 lots of 20. Well, I'm going to do 2 times 12, which is 24, and then just add this 0 on the end. Okay, 2 12s are 24, and then add the 0 on the end. So she's paid £240. She owes £265. 265, take away 240. You might be able to do that in your head. £25. Question 9 says, rearrange this formula to make x the subject. Well, we want x to be on its own. We've currently got a take 2. The opposite of take 2 is add 2. And on the left hand side, you've got your y and then the add 2 that you just wrote down. The equal sign stays, and this take 2 add 2 vanishes. So you're just left with x. X is now the subject because it's on its own. Part B says, rearrange to make D the subject. So I want D to be on its own. Well, when you've got two things squished together, there's a multiplication. So we're timesing by pi. The opposite of that is to divide by pi. And we need to do it to both sides. Left hand side, c divided by pi just looks like this. C divided by pi. And the opposite of timesing pi is dividing pi, so they go away. And you're just left with D. Question 10, and we're looking for the equation of these straight line graphs. Well, this one here crosses the x-axis at 3. That is x equals 3, not y equals 3. A lot of people put y equals 3 because it goes up and down. It crosses the x-axis at 3. So x equals 3. This one just needs to be aware of, but you can check if you're not sure. Every point, x and y has the same value. So that is x equals y, or commonly more known as y equals x. Part B has to sketch y equals x squared. Well, y equals x squared is a curved graph like this. Hits 0, 0, and curves back up the other side. That there is y equals x squared. Question 11, we've got some ingredients, flour, butter and sugar. And then it says flour is 5 parts, to butter is 4 parts. Then in the second ratio, we've got butter is 2 parts and sugar is 1 part. And what we're looking for is flour, butter and sugar together. So I'm going to rewrite those ratios down. We've got flour is 5 parts, butter is 4 parts. That's the first ratio. In the second ratio, we've got butter is 2 parts, and then we've got sugar is 1 part. What I'm looking to do is combine this into a single ratio. If we look at that right hand ratio, I can maybe double this and we'll see what happens. Okay, so 2 times 2 is 4. 1 times 2 is 2. And what you can hopefully see is now the butter part of these ratios is both 4. I've made those match. So that allows me to write a single ratio flour to butter to sugar. The flour will be 5. The butter is this matching 4. And the sugar is this 2. That is now a single 3-part ratio for flour, butter and sugar. I combine these together. The question says the total weight of flour, butter and sugar is 770 grams. What I need to do is split that into this ratio. So I'm going to add these parts together first. 5, add 4, add 2 is 11. There are 11 parts to my ratio. I need to do 770 divided by 11. Well, 77 divided by 11 is 7. So 770 divided by 11 must be 70. So now I know that each part of this ratio is worth 70. For the flour, I need to do 5 lots of 70. Well, 5 7s are 35. Then I'm going to whack this 0 on the end. For butter, I need to do 4 lots of 70. And again, 4 7s are 28. Whack a 0 on the end. And for sugar, I need to do 2 lots of 70. 2 7s are 14. And whack a 0 on the end. They are the answers to the weight of each item. Question 12 says work out 8 divided by 0.4. I'm going to write that as a fraction. Why? Because that allows me to create an equivalent fraction, a much nicer calculation. If I times the top and the bottom by 10, I get 80. And 0.4 times 10 is 4. And 80 divided by 4 is just 20. That is the same answer to both calculations. Part B says, write each number to one significant figure to estimate this calculation. Well, one significant figure is just about kind of which number this is closest to. 22.1, don't go for 22, go for 20. Make it even easier, as easy as possible. 37 rounds to 40 when we round into one significant figure. And 1.9 rounds to 2. Work out this top line. 2 times 4 is 8. And then there's 2 zeros on the end. And 2 is just 2. And 800 divided by 2 is 400. Question 13. We're looking to write 0.00316 in standard form. Well, I need to take this 3, 1 and 6 and make this a number that's bigger than 1 but less than 10. So I'm looking to put a decimal point somewhere. It's going to go there. 3.16 is now bigger than 1 but smaller than 10. So I've put my decimal point here in this number. In order to create the number that I started with, I'm going to go 1, 2, 3 jumps to the left. So what I write is 3.16 times 10. To get these jumps to the left, I need to put a negative 3. 3 is the amount of jumps, and the negative is because I bounce into the left. Part B, we're asked to work out a calculation. Well, 2 times 10 squared is 2 times 10 once, twice. And 4 times 10 to the power of 5 is 4 times 10 once, 2, 3, 4, 5 times. Now, I didn't actually need to do this because this is a multiplication. I thought it were an addition. But anyway, no matter. I'm going to do 2 times 4, which is 8. And then I need 1, 2, 3, 4, 5, 6, 7 zeros on the end. 1, 2, 3, 4, 5, 6, 7 zeros. It does say give your answer in standard form. So I need, again, a number that's bigger than 1 but less than 10. Put my decimal point there. And I'm going to bounce once, twice, 3, 4, 5, 6, 7 times to the end. So we've got 8 times 10 to the 7. Question 14, it explains what a Fibonacci sequence is. It says you add together the two previous terms. So 2 add 5 is 7. 5 add 7 is 12. So we need to add two numbers together to make the next number. So I'm going to do 7 add 12. 7 add 12 is 19. And then the next number I need to do 12 add 19. Well, 19 add 2 is 21. Add the 10 is 31. If we're going backwards, then this add this makes 34. So to work backwards, I need to do 34, take 22. And I'll get the previous number. 4 take 2 is 2, 3 take 2 is 1. This must be 12. Then again, to work backwards, I need to do 22 take 12. Well, that's just 10. And finally, 12 take 10 is just 2. Question 15, we've got quite a meaty page of algebra. First question, we're looking to multiply out a double bracket. So I like to use a grid method for this. Draw my grid like that. This is a multiplication. And I've got 3x take 2y in one bracket. And then the other bracket is x plus y. And I need to just work out these multiplications. So 3x times x is 3x squared. Minus 2y times x is just minus 2xy. Y times 3x is 3xy. And minus 2y times y, there's definitely a y squared, but there's negative times positive, minus 2y squared. We've got the 2 and the y squared. Just double check, we've got 3xy's and taking 2xy's. So if you've got 3 of something and you take 2 of them away, you're left with 1. So altogether we've got 3x squared. 3xy take 2xy is just 1xy. Don't actually need that 1, but it doesn't hurt. And then take 2y squareds. Part B, we've just got some more brackets to expand, and it's kind of giving us the answer. And it wants us to work out what C and what D are. So it's quite a tricky one, this, but let's have a look. We've got to do 3 times 2x. That there is 6x. And then we've got to do 3 times D. And 3 times D is 3d. So I've expanded that first bracket at least. Then we've got to do C times x. Well, that's just cx. And we've got to do C times 5. And C times 5 is just 5c. Now what we're told is we're looking for 10 x's. Well, I've got 6x and some more x's. To get up to 10 x's, C must be 4. 6 x's, add 4 x's is the 10 x's that I'm looking for. So I've got that bit sorted. Now I know that C is 4, I can say, well, that is 4. And this entire thing here becomes 5 times 4, which is 20. What we're actually looking for in the answer is 17. So we've got 20 and 3 D's, and we're trying to get to 17. Well, 20 and something makes 17. This altogether must be minus 3. 20 and minus 3 makes 17. And in order to make this minus 3, D must equal minus 1. 3 times minus 1 is the minus 3 that I need. Part C, solve by factorising. Again, it's quite difficult, this page of algebra. It is worth 11 marks altogether. What we're looking for when we're factorising this type of expression is two numbers that add to make the middle thing and times to make the end thing. So two numbers that add to minus 7 but times to positive 10, I think -5 and -2. -5 and -2 makes -7. -5 times -2 makes positive 10. So they're the two numbers I'm looking for, and those two numbers go into my brackets. Factorising an expression like this, where you've got squared terms, x terms, and numbers, will always go into double brackets. Still equals 0. And then when you've managed to factorise the quadratic, that's that factorised, we can solve it. Well, if you've got x minus 5 in one bracket, then your x is positive 5. And if you've got x minus 2 in another bracket, then x is positive 2. We've got two spinners, A and B, being spun. And when they're spun, the numbers are multiplied together. We just need to complete this table. So I need to do 9 times 4, which is 36. And then I need to do 5 times 9, which is 45. Part B is looking at probabilities from this table. And we're looking at even numbers and prime numbers. And there's the working that my mate Jeff has done. We just need to figure out why this is wrong. So I'm going to look at even numbers first. Even numbers are your 2 times table. So anything in the 2 times table. And that's it. 1, 2, 3, 4, 5, 6. So the probability of an even number is definitely 6 out of 4, 8, 12. Nothing wrong with that, Jeff. If we move on and look at the prime numbers, well, prime numbers you just need to be aware of. They are 2, 3, 5, 7, 11. Anything that you will struggle to divide in your head usually is a prime number. Basically, they only divide exactly by one of themselves. So I'm just going to identify my prime numbers. There's a prime. Prime. 5 is prime, and they're the only prime numbers in that table. So the prime numbers, definitely 1, 2, 3 out of 12. Not wrong there neither, Jeff. He says the probability that an outcome is even or prime is 6 12s added to 3 12s, which is 9 12s. The problem with Jeff's working is he's counted this one twice. Okay, 2 is even and prime. So we could write that in his mistake. He's counted 2 twice, and the fact that it says even or prime means we only need to count this once. So the correct answer will be 1, 2, 3, 4, 5, 6, 7, 8. Talks about the depth of water being 57.8 centimeters, and it decreases, so that means goes down by 0.3 centimeters every day. It's going to keep going down at that rate, and it says after how many days will it have reached 54.2 centimeters. I think the first thing I need to do is look for the difference in these two measurements. So if I start with that, 57.8, subtract 54.2, that's going to tell me how much the water has gone down by. So 8 take 2 is 6, decimal, decimal, decimal. 7 take 4 is 3, and 5 take 5 is 0. So the water goes down by 3.6 centimeters. It says we go down by 0.3 centimeters every day. So I need to know how many 0.3s go into 3.6. So I need to do 3.6 divided by 0.3. If I write that as a fraction, I'm going to get 3.6 over 0.3. Why would I write this as a fraction? Well, it allows me to write a nicer calculation. If I times the top and bottom by 10, I get 36 divided by 3, which is 12. And this is a much easier calculation than this. Because it's an equivalent fraction, it gives the same answer. The answer is 12 days. Part B says if the depth of the water decreases at a slower rate, what will that have on the answer to to part A. Well, if the water is going down by less amount per day, it's going to take more days to drop to this level. We've got my mate Emily spending £2,400 on holiday, and this is 20% more than she spent last year. And we want to know how much she spent last year. So it's typical reverse percentage question. What we want to know is what she spent in 2016, which we're going to call 100%. In 2017, we know what she spent. It was 20% more than this. So she spent 120%, 20% more than what she spent in 2016. And that came out at 2,400. So if we know 120% is 2,400, what we're looking to do is scale this down to find my 100%. Several ways to do this. I like to just kind of halve in to start with, just get a feel for the numbers. 60% would be 1,200. Just halving and halving. I might divide by 3 this time to give me 20%. And divide by 3 on this side. And 1,200 divided by 3 is 400. 20% is useful because I've got 120% here. So if 20% is 400, and 120% is 2,400, then 100% must be 2,400, take the 400, which is £2,000. Question 19, we've got two triangles, A and B. And what we're asked to do first is draw the image of triangle A after a rotation of 180 about 0, 0. And it's difficult to show this using the device I'm using. You'd grab some tracing paper. You would trace triangle A. You would put your pencil on 0, 0, and you'd spin this around your tracing paper 180 degrees, half a turn. And if you do that, your triangle is going to line up right there. Part 2 says draw the image of triangle A after a translation by this vector. Well, when you've got a vector like this top number is left and right, and positive numbers go right, and then this bottom number is up and down. Positive numbers go up, so negative numbers go down. So this is saying move A 2 right and 7 down. So pick any point and just go 1, 2 right, and then 1, 2, 3, 4, 5, 6, 7 down. That there is where the top of your triangle is going to finish. And then we can just draw the triangle. The triangle is 1, 2, 3, 4 down, 1, 2, 3, 4 down, 2 across, 2 across, and then just connect those together. And I've just seen my initial triangle weren't tall enough. It should have been 4 high. So I'm just going to change that now rather than start the entire question again. That's better. Part B says describe fully the single transformation that maps A onto B. So we're going from this triangle to this triangle. Well, first things first, even though it gets smaller, we call that an enlargement. Okay, I know that sounds weird, but even though we're going from a big triangle to a small triangle, it's still called an enlargement. We need a scale factor. And that's saying how many times bigger or smaller is this to this. Well, if we go from 4 high to 2 high, that's scale factor of 1/2. We're halving the triangle. And then the hardest bit to find is something called the centre, or the centre of enlargement. The best way to do this is clear your diagram. And then I'm going to draw some straight lines from this point to this point, and I'm going to carry on. So they'll be a bit rough, these, but I'll try my best. So just connected those matching points and carried on. I'll do the same with this line and with this point and this point. Connect them and carry on. And then I could do the same with this point and this point, but I'm only going to draw the same line, look. And what I'm looking for is a point where all these lines cross over each other. It's right there, look. That's your centre. So it's -1 and up to 2. Here we've got a table showing number of computers sold in a shop, and we've got from 2015 to 2017. And all we're asked to do is complete the graph using 2017 information, which is here. So we've got Q1, 27 computers sold. So across Q1, where's 27? Well, it's 10, 20, that would be 30. So somewhere around there, 27. Q2 is 40 computers. There's Q2. That's nice. That's bang on 40. Q3 is 30. Q3, 10, 20, 30. And then Q4 would be 58. So there's Q4. Right up to 50. That would be 55. That's 60. So again, somewhere just before 60 there. And what we do is connect these points up. Part B says Tom adds the 3 results for Q1 and he adds the 3 results for Q4, and it says the ratio Q1 to Q4 is 2 to 5. Is he correct? So I'm going to look at Q1 first and see what's happening there. Q1, we've got 13, 20 and 27. So let's add those together. And we get 7 add 3 is 10. 2, 3, 4, 5, that would be 60. Q4, we've got 45, 47 and 58. So let's add those together. Five add 7 is 12. Add 8 is 20. And then we've got 4, 8, 9, 10. That would be 15. So what we've got here, Q1 is 60. And Q4 is 150. And we're trying to see if that simplifies to this ratio, 2 to 5. So let's start simplifying this. If we look at both sides, they'll definitely both divide by 10. And you get 6 to 15. These are both in the 3 times table, so divide by 3, 2 to 5. Exactly what Tom says. Make sure you say the word yes, he is correct. Part C, it says make 2 comments about the sales from 2015 to 2017. Just quickly look back at the graph and you'll see what I'm about to explain. We can definitely say that in Q4, he sells more. All right, every time in Q4 we're at the top of the graph, so he's always selling more in Q4. And what we can also say is that the sales increase over the 3 years. The graph is kind of slowly going like this, up and up and up and up, so he's slowly selling more and more computers. And we're going to use that in part D, where Tom predicts he'll sell more than 60 computers in the 4th quarter of 2018. What assumption is he making? That upwards trend is going to continue. So, and final question on this exam, question 21. We've got a circle and another circle inside of it. We're just told the radius of the large circle is 6. We don't know the radius of the circle inside, but we're looking for an expression in terms of pi and x for the shaded area. Okay, I think all I can do first is to get this, the area of the large circle. And the area of any circle is just pi r squared. My radius for that circle is 6. So that's pi times 6 squared. 6 sixes are 36. That area is 36 pi. There's not much we can do with the small circle because we don't know its radius other than its x. So we can say the area is still pi r squared where the radius is just x. So that's just pi x squared. The shaded region is this bit. And in order to get the shaded region, we need the blue circle, take away the red circle. So what we need to do is to say the shaded bit is going to be the blue circle, 36 pi, take away the red circle, which is pi x squared.